All right, thank you, Ori. I couldn't have given a better introduction to what we're going to talk about next. So we're here from NeuroBlade. You might have seen our logo earlier. What we produce is a hardware accelerator for analytics. The processor is called SQL Processing Unit, or the SPU. We don't actually process SQL. We'll get into the details in a second. This is the one without the heatsink. The reason I bring it up is because if I gave this to one of you, and you guys went to your infrastructure team, said, hey, can we run this? Every single one of them would say yes. And the reason they would say yes is, what do you need? A free PCIe slot? Right now, if you have an analytics server, you don't have anything in that PCIe slot anyway. The second, this is the smallest form factor around, which means you don't need a special slot. You don't need a big slot. You don't need a double wide slot. It just works. And the third is the power requirements aren't that much. There is a small auxiliary power input that's required, but it fits within every server spec. The second thing is we thought long and hard about how do we integrate. And we picked Velox and we went down the Velox path first. And a lot of that is the mentorship, thanks to the mentorship we got from Ori and Pedro and Sridhar and the rest of the Velox team. We also realized that we were not building a Velox accelerator. We were building an accelerator for analytics. We need to do a second. And so we did ClickHouse. And the intention of this was to get the software model correct. And we'll talk briefly on the software model today. Because while we are a hardware company, we don't expose the FPGA and the underlying details of how to program a processor. It's not necessary. In fact, it overly complicates the integration. The other benefit of having done two is we can say with confidence, if you wanted to run it on something else, that will work also. The model has proven itself. This slide is our homage to the Velox team. It's inspired by their initial graphic, slightly modified to show where we fit, and sometimes where we fit even without Velox. On the right-hand side is a standard stack. You've got Spark, you've got Presto, and then you've got ClickHouse. On the left-hand side, you see how we fit. We're below the runtime, we're below the worker, and you'll hear that theme as we talk. It was an intentional choice to say, hey, we fit at the worker level. It gives a very clean integration. And we benefit from all of the work that everyone is doing on the optimizer. And in fact, if you do more work in Velox, and we've heard several talks yesterday, we'll hear more today about the optimizations coming into Velox, we benefit from those as well. We heard about Iceberg yesterday. The nice thing about our integration model is we're agnostic to the table format. So whether you're Hive, you're Iceberg, you choose Hoodie, Delta Lake, or something else, it's somewhat immaterial to us. The integration model allows all of these higher level concepts to just work out of the box. What we care about and what we work on is the file format. So today, out of the box, we support Parquet, we support ClickHouse. We'll learn more about Nimble later today. That's something we could support in the future, as well as any other file format that comes. Now, the file format is particularly important because we wanted to make sure you don't have to do anything to your data in order to make this work. But it also means we need to support the things that Ori talked about. You have to decompress, you have to decode, because all that comes as part of the files that you've created already in your data center and your data lake. We also spent a lot of time thinking about how we merge and how we bring results back into Velox. And one of the realizations was we have to be zero copy. The data has to be there without any transformation whatsoever, because that adds a huge latency component. And so we support Velox out of the box, we support Arrow out of the box. What we learned yesterday is there's more work. Now we have to bring them together. So you'll have just Arrow, which will support string view and list view. But that's already supported. And we did the same with ClickHouse. So again, zero copy is super important. It makes sure that we keep the performance that we provide. This is a very simplified view of the world that you know better than I do. On the right-hand side, Krishna wrote a SQL query, probably the world's simplest SQL query, just to be illustrative. The optimizer creates a physical plan. This is what the part of the world that we also don't get visibility into, but optimizer changes come, they benefit us and Velox. Velox gets a task. Please execute. One after another. That task now comes to us. So we say SQL Processing Unit, we're really a task processing unit. And we execute one after another, but we added another stage within Velox. We call it task planning. We also use the term task segregation. We heard a lot about fallback yesterday. We heard about it a little bit from Ori today. We think about it a little bit differently. You fall back when you can't execute something. The way we think about it is we know what we can execute, so let's plan for it ahead of time. And so in task segregation, we segregate the task operators into what can we execute on the SPU, what needs to be operated on the CPU. And we work better together. So here's a very high-level view of the integration model. All the way on the right-hand side, so the right-hand side, left and right-hand side is coordinator, optimizer, coordinator. What happens at the optimizer? Having the you create a task, have to segregate. Okay. You driven. Here the SPU driven with the sounds off. Turns out it's not as we say it is. We're making it right. We provide integration. It understands the capability of you as an integrator. Don't have. And we say this is what we recommend. And then when you we queue the query and then it sits there and it give us data. So it's following the same split model for execution. When you get coordinator driven, this is where you add all the splits and associate them with the query that you've already put in the queue. The SPU. Now one of the challenges that as chip designers we have to deal with is memory. How do you think about memory? How do you think about orchestration of execution and we split the world into two parts. And the majority of operations, no memory. As we go through. And then there's certain you're storing some data. For example, again, there's no interface. Using data. Talk about how we set record values. We use some of the nomenclature from the aero community. Because again, we're trying to make it familiar to everyone. And once we're next, you have the CPU part. Forget about that. Velox knows how to do that. It does. When Velox understands CPUs, that's also an most of our time, a lot of our we'll share some benchmark results today. Summary ways go deeper. On stage. The big challenge. We heard a lot of you need to hear about how much faster can we than something else. But what's the baseline? One of the fears we live, we configure it one way. And someone smarter comes along and says, "Oh, if you configured it some other way, your baseline would change." And so what we did was started with the Velox community, with the Presto native. So let's create a baseline. That means all of the modules that we're all working have the same common, and so we can evaluate the trade-offs together. So join us. Join us. Slide. Join us. The numbers are today, but absent that common base, even though that's one. So in our so four nodes, Prestissimo, Velox, 64 vCPUs, half a terabyte of RAM. This is for the benefit of and then the accelerator range. The only difference was we added. And when I say added every node. So there's four. Now the nice thing is you can choose how to orchestrate with every node. You can grow the cluster, you can grow with the you can shrink the same way. All of the same benchmark. Kept it simple. There's no resiliency here. It's just we ran the queries and and we kept configuration. That's also important. We wanted to make apples to apples comparison. Now, not every configuration but I would say now, when we ran the performance test, and this is a summary of there's a range. Why is it? It turns out there's variation at all levels of execution, even when you keep everything constant. Because Velox as an offload accelerator, we never be a constant. But even when we are, you'll still see a because the baseline. But and then by generation, you'll also so there's a range, and this translate. Now the specifics of the also brought. We chose to put one number based on that we run. But again, with your now, why do I carry and why did I this versus this? Is because this is the production. Available. Not today. Tomorrow. We have detailed results. We have ongoing integration. Velox and SlickHouse are two that I talked about. I'm not limited to just those two. I just can't talk about the rest. And what we're encouraging remotely, experiment. Obviously. Join us, and then share performance together and compare with each other.
Could you go back to your optimizer-driven slide? I just want to clarify where that optimizer is.
Yeah.
Sitting.
This one?
Right. So the optimizer-driven, which optimizer is this? Is this like you have a special optimizer on the worker, which sort of decides how to fragment the task plan? Is that?
No, we do nothing with the optimizer. This is Prestissimo.
So, this is Prestissimo, right? So,
yes.
So then the question is, can you go back to the previous slide? So why is the task planning local and not at the optimizer? Because like this is a general question, not specific to this. So
Yeah.
because the Presto optimizer has statistics and it has more information, and it can do a single plan fragment and share it across all the clusters. And maybe some table joins are or some cardinality is very low, and you don't need the SPU. So do you have any thoughts on? I mean, if it should be a local or should be on the coordinator, this task planning?
Yeah. There's nothing that prevents you from doing it at the optimizer. It was a choice we made in what we're building and how we're integrating. We wanted to leverage everything that was being put together in Velox and benefit from it. But you could implement in the optimizer.
So we're actually trying to build a new SPI V2 in Presto where we could query a worker about the capabilities, and then the optimizer is now the Presto optimizer is now aware of what the worker is capable of, and then do this like plan fragment more smartly. So would that be interested like for your use cases,
Yeah.
especially?
I think the optimizer would benefit and the overall performance would benefit.
Got it. Cool.
It was a choice for us in terms of how we step forward with the first step with the
Got it.
community.
Yeah, it makes sense. Yeah.
That was it. Sure.
Hey, is the accelerator designed to work in a streaming fashion, or is it going to be like using the onboard memory to bounce off just for the intermediate data, or is it going to move the data next to the your compute engines and then operate on it? Or do you see both?
It's a fully streaming processor. We're reading data directly from your local NVMe drives, or you're reading data directly from memory. Doing the operations, the only thing we use memory for is when you need storage. So if you're maintaining your aggregations, you need to store it somewhere to build the aggregation itself.
So it's only
If
for
you're
the
doing
intermediate.
scans, filters, there's no memory involved.
Okay, it's only for the intermediate functions. It's not for the table itself. You're not moving the data from, let's say, host memory onto the accelerator memory for
No.
compute. No.
No, absolutely not.
Thank you.
That was one of our key innovations, was to eliminate that step altogether.